Okay, so what we see here is another one of these compositions of inverse trigonometric and regular trigonometric function. It says use a sketch to find the exact value of the following expression. You certainly could, right? Because as we said before, when you're dealing, and we're going to work from the inside out here, okay? I always want to work from the inside out. So we're going to start in these brackets. We're not going to do anything with sine yet. We're going to evaluate this inverse trigonometric function first, right? And as we've said before, the input to a trigonometric function, this is either the adjacent side over the hypotenuse, where we could sketch a right triangle that has an angle where this is the adjacent side and this is the hypotenuse. Okay, I mean, we could just do that real quick here. All right, we're talking about some angle that has a cosine of radical 2 over 2. We can make the adjacent side 2, and we can make the hypotenuse 2. Okay, so then we would take this angle, and there's another video on this where we have no choice but to use a right triangle. So I'll reference that. Definitely look for that coming up. Okay, we could go this route, but the other possibility for the input to an inverse trigonometric function is an x coordinate, and specifically an x coordinate that we see on the unit circle. And this is one of those x coordinates that you should be familiar with, right? So I'm going to write this, even though it's written as cosine inverse, I'm going to write it as arc cosine, and only for the purpose of underlining the fact that arc means a piece of the circle. Okay, so what piece of the circle has an x coordinate of radical 2 over 2? And that piece, that output for this entire thing is pi over 4. So now I'm replacing that entire expression with its value, and its value is the pi value that has an x coordinate of radical 2 over 2. And then when we take the sine of that value, now we're not doing inverse trig anymore. Now we're doing the regular trig functions. And when we take the sine of an angle, the output is either opposite over hypotenuse ratio or a y coordinate. And since this angle is on the unit circle, I'm going to find the y coordinate of that angle, which is radical 2 over 2. So that's our final answer for this one. So really what it comes down to is understanding what the input can be, understanding what the output is, replacing this huge mess with that output, and then reevaluating with the outside function. Okay.